In this video we're going to talk about the parabola and look at some key features for the parabola. So you can see here on this graph here, this is a basic parabola. It's the most basic one of all. This is the graph of y equals x squared. Now let's have a look at some of the key features on this graph. You can see that it goes down, 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 turns the corner and then goes up, 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 up. Now this key feature here is called the turning point. Let's call it TP for short. And the coordinate of the turning point is 0, 0 on this graph. Other key features, we can see that the graph is symmetrical. We can also tell us that the axis of symmetry, or the mirror line of the line of symmetry, but it's called the axis of symmetry, is at the y-axis. Now to find the axis of symmetry, you can actually use the x-coordinate of the turning point. Okay, so this here, the x-coordinate, gives us what we call the equation for the line of symmetry. Okay, so we can see the axis of symmetry for this is the line x equals 0. We also can see that this graph has a y-intercept here at 0. Now, just talking about parabolas, this is the most important nonlinear graph of all. And for example, things like if a ball is thrown or if water streams out of a garden hose, the path that that object follows is a parabolic shape, hence the parabola. And the parabola is the graph of a quadratic relation, and obviously the most basic being y equals x squared. Let's have a look at one that you might be able to relate with sort of throwing a javelin or something like this. This is the graph of y equals minus x squared. And it also has very similar key features to the one above. We can see it's actually a reflection of the one above. It's been reflected in the x-axis. But it also has a turning point at 0, 0. We can call this a maximum though. On the previous one, it was a minimum point. This is now a maximum point because the parabola is going up this way. We can also see that it has a y-intercept of 0, and we can also see that it has an axis of symmetry at the line x equals 0. It doesn't have any x-intercepts at this point. There are no points where this graph cuts the x-axis. It touches the x-axis, but it doesn't cut the x-axis. Let's have a look at a different parabola. Now we'll talk about how you find the equation of parabolas later on. But the key features for this particular parabola are that it does cut the x-axis. Now we can see that it cuts the x-axis near the point 2. It's not exactly 2. And near the point 6. And in actual fact, if you've watched my video on how to factorize quadratics, when you factorize a quadratic, you're actually putting the line you're actually substituting when y equals 0 into the formula, and that finds the x-intercepts. So when you're factorizing using the null factor theorem or any other method that you've learned, you're actually finding the 2 points at which the equation you've got cuts the x-axis. So also on this graph, let's look at other key features. Can't actually see what the y-intercept is on this particular graph at the moment, but there is one. It will be cutting further up, and to find that we would substitute, of course, when x equals 0 into the formula. Now, other key features. It has a turning point. This turning point, we'll call it TP, is located at the coordinate 4, minus 7. And so therefore our axis of symmetry is at the line x equals 4. Okay, so x equals 4 is our axis of symmetry. Now you'll be familiar with some quadratic equations if you've looked at my factorizing videos. You'll notice that quadratics can be written in two main forms. The first form I'm going to call general form, and this is when it's written in the form y equals ax squared plus bx plus c. The other point is turning point form. I call it turning point form. I've missed the point out there, but there should be turning point form. And this is in the form of y equals a bracket x minus h all squared plus k. Now I'll explain in a later video what the a, the h and the k actually stand for. But you may see this sort of form when you complete the square of any quadratic function. Sometimes you're given it in this form. It doesn't matter which form you're given, you can always do things with it, like factorize and so on and so forth. All of these have common things. You can find the x-intercept of both of these types of equations by subbing in when y equals 0, and you can find the y-intercept by subbing in when x equals 0.